Hello, how are you doing? We'll start in a few minutes.
Hello,
Ah,
Miss Wen?
yes,
Okay, wait, I don't know if my name is on here or not. Let me actually
it
check.
shows 1+.
Okay, good Lord. Okay, let me rename that. Why does it say that? Okay, all
That's
right.
okay. What
Yeah.
I do with attendance is I will have the student type into the chat their name and stuff at the end. So if you don't have a
Okay,
chance to choose, okay,
okay,
all
all
right.
right. So, me and my brother were actually here at the park because our car broke down. We were trying to go get the stuff, and we were just gonna be on call while in class, and
I'm
car
sorry
broke.
to hear that.
Yeah. So, but we're here. We're just kind of like we'll just be in this class for now, and then hopefully once we get the AAA to come in with the thing, we can go to the school to pick up the
Makerspace.
stuff. Yeah, the
Okay,
makerspace. So just
that's
heads
no
up. I'm so
problem.
sorry about that.
I
We
saw your
Yeah.
email.
All
Yeah.
right. Thank you so much. I'm so
Uh,
sorry about that.
That's okay. I will release the recorded session after maybe about 5 o'clock. And whenever YouTube allow me to finish upload, it does take a little bit longer during the day, but I do record all my session and it will be released under my
Mhm.
playlist. Okay?
Okay. Yeah.
No
Thank you so much
problem.
for that.
I
And then my
appreciate
brother
that.
is yeah, and my brother is here. We left his phone at home, so unfortunately, so if he's here, you could say
Oh
hi.
yeah. No problem. So,
Yeah.
hi.
So yeah,
Yeah,
just
so later on in case you drop off, just type your name into the chat so that way I
okay.
get you, okay?
Oh yeah, definitely. Actually, why don't I do that now, just in case, considering
Yep.
uh that way, if it does, yeah, considering I have like 32% at the moment, so we'll see. I can
All right.
so sorry.
Okay, so as everybody heard, welcome to CIS833A. You're in for a treat. If in case you get drop off or if you're in the middle of something, you can type your name into the chat and that way I have my chat record so I can enter your attendance. This is a non-credit course, so I'm going to go ahead and go into screen share and I give you a brief overview of the course, your syllabus, and how you would navigate if you have access to Canvas. If you haven't had access to Canvas, it normally takes a few hours after you register for the course. So they will sync it with the database. So it does take a couple of hours at least to get started. Okay, but that's okay. I'm not using Zoom within Canvas. So all right. 1 second. Let me open up my syllabus and then we'll talk about what we need to do. Okay. Now, in this class, you are required to use Arduino. If you have your own kit, that's okay. But however, you will need to have all the electronics components. So it would be better if you pick up all the components from iMake Innovation Center because they will provide you with the checkout option. And then when you're done with the course, you can always return it. Okay. And if you haven't picked that up yet, you can still do that this week. They're open from 7 a.m. to 5 p.m. Okay, so this is a non-credit course. You will earn a badge if you complete this course, and if you complete the whole series, you will get a badge for the certificate and also the badge for the course. You can link your badges. I use a badge company that you can link on LinkedIn. This is microcontroller, so you will be learning C programming mostly. We will touch a little bit on C++, how that will correlate, but all microcontroller uses C programming pretty much. And this is a regular meet. We are meeting 2 to 4. On Tuesday, I do have office hours between 4 and 5 in case you need help. I have another class that I'm teaching online, which is CIS30A, Introduction to Python Programming. So I will make myself available even though the summer intersession faculty doesn't require, but I found that it would be helpful to the students. Um, In case if you miss class, I will have recorded video sessions being released via YouTube, and it will be linked to the Canvas page. So if if you like, you can always go back and watch those. Okay, and I organize everything by playlist if you subscribe to my channel. Um, so in this class, what are we learning? We're going to talk about microcontroller, specifically Arduino Uno, which is the model for Arduino. And Arduino is one of the boards that is it's commonly found, it's easy to use. The community supports it really well. It's open source. Um, so if you haven't gotten the board yet, if you haven't gotten the equipment, you can follow up throughout the week. Okay. So for the microcontroller, we're gonna talk about the power supply, how each of the components will be, and we're gonna touch on the history of Arduino and what kind of models you're gonna be looking at. Now, other microcontrollers you might see in the markets are more on mainstream business use, or IBM. You would see Texas Instrument. They are one of the bigger companies that produce that. So in this class, we are going to use the Uno, okay? And then we will talk about the clone boards, boards that are being produced by Adafruit or other companies that look very close to Arduino. And then we will use the IDE for Arduino to write a program. And for Arduino, that's going to be called Sketch. So each of the file that you create to program your microcontroller is a sketch. And a sketch can be organized into a sketch book. So and with microcontrollers is that you only need to upload it once. As long as you give power to it, it's always going to be doing the things that you instruct it to do. So it's very cool. So I can plug my Arduino to a power bank, right? A good enough power bank, and I can have it run. So if you're familiar with like Christmas lights kit that they sell at like Home Depot, or even some of the smart devices, most of the smart devices use some kind of microcontroller, and or sometimes that will be embedded system. So and we'll talk about embedded systems later on. If you're taking my CIS833B, I will touch more on Raspberry Pi, how it is an embedded system. And so in the programming side, you are going to learn about variables. It's going to look very similar to C++ for those of you who learn C++. We're going to work with functions. We're going to use a lot of the commands. So basically, the commands are pre-built into the library for the microcontroller. And so if we wanted to do certain things, we would use the exact command that is already built in. We are going to make it repeat, and we're going to apply conditions. So for example, if you're looking at streetlights use sensors and microcontrollers, and all of those are connected to the larger network for the city and the county and so on. So then the condition would be applied something like, when so many cars are at the stop line, right? It will then turns green, or when the car has been waiting for 3 minutes or so, then it would turn green for the car to go. So we are going to apply conditions, and you are going to use sensors in this class, really cool ones. You're going to know how to be using light sensors, something like solar panel that would use. You will be using proximity sensors, ultrasonic sensors which sense sound. Um, how far is the sound waves going to travel, and that's if it hits a certain solid object like the wall, it would then know. So if you're familiar with like the Roomba, those robot vacuum cleaner, all of those use some kind of proximity sensor, and usually it uses ultrasonic sensor. That means it sends out some kind of waves, right? Sound waves. And if it bounces back, it would know how far or how close it is to avoid different objects. And you see this type of technology being implemented for, automated cars, a lot of like robotics type of equipment, and so on. We'll touch on constant and data type, in different lessons. So you would see some repetition of all of these areas in programming and concepts. And then we'll work on syntax and the format for how you would write in your Arduino IDE. And then we would learn how to write comments, indentations. Indentations is important for C or C++. So in our code block, we would learn how to indent. And then we'll touch on containers, containers that could contain values, a group of values that will be arrays. We'll touch on different arrays that would have string. So this is when you would start using more of like a screen to display a certain text on screen on LCD screen, which comes with the Arduino kit. Or if you wanted to like have a digital poster board, you can actually use an Arduino to do that. So it's very cool. We'll learn about input output starting today, on how we would use digital and analog, right? So if I wanted to turn on the LED, I would then connect it to the digital pins, where if I wanted to use speaker, I would then tie that into analog, and we'll talk about the differences. And then we'll get into more of the library, how to create files, how we can look at math functions, because if you ever work with building a robot with microcontrollers, you would see that you would have to apply mathematical equations. So that way it would then know we can apply physics with that, right? Be able to lift, be able to navigate, be able to have different type of sensors working for us. Um, and then we'll talk about interrupts, and then some of the I/O. Now, microcontrollers like the Arduino have a very small storage. So if you write a very large file, you are going to be limited to the flash capacity. And it's you only have to upload it once, like I said, so it's stored there permanently until you write the next program, and then it's just going to overwrite it. But what we can do is we can save our files in our different sketch in different names, so that way you can always revert to that and re-upload it. So if you write a program, basically what I'm saying is that once you upload it, it's going to take over, and it's going to use the instruction that you write in that program for that microcontroller. So if you wanted to revert back to another program, you have to re-upload the other program. Otherwise, so it's going to store once. Um, and the size of that is usually in just megabytes, so you don't really have a very large capacity that comes with these. Now, the industrial microcontroller, you're going to see that they would have additional storage, and some of them actually have their own separate RAM. So, but most of the time you would see that it is a storage chip that's built onto the actual microboard. Okay. We will be working with LCD display, and that way, you would see on how that would be used. So in the case where if you wanted to build um, a device that would display some kind of text, you would be able to do that. And on the Arduino Uno, it doesn't come with Wi-Fi capability. So if you wanted to adapt it for web services, you have to adapt it with the Wi-Fi sensor. Now, on some of the other model, you would see that they would have Wi-Fi capability. So unlike the Raspberry Pi, microcontroller like Arduino doesn't have a lot of complex components for communication. So if you wanted to make it communicate, you have to adapt an additional smaller, right, sensor, which is a small board that's going to be attaching to that, which is very affordable actually. You can get a whole sensor kit for like less than about $20 or so. So we'll touch on some of the libraries and the built-in libraries. We might look into some of the classes area. This class is not fully geared for full-blown programming, but it's geared to show you how you can have hands-on and build components and be able to write instructions for your microcontroller to execute certain tasks. And we will do very cool projects. Okay, so here's your learning objectives. We are going to talk about microcontroller architecture, the purpose, and how that's used in modern electronics. We are going to assemble circuits using breadboards, wires, and different components. That's why it's important for you to have those kits. And we are going to use the IDE for Arduino to be able to perform a certain task, like turn on LED, make sound, you know, have turn, show us display of different values on how light is in the room. So if you wanted to do some kind of light sensor stuff, which we will be using the photo cell or the photo resistors for those. Okay. Now, I'm not using a specific book, but this is a book that I would recommend if you wanted to continue. And if you pick up the Arduino kit from iMake Innovation Center, it comes with a book. Some of the exercises in that book is uh, not 100% working. So I just want you to know that, even though they updated, some exercises have really high ratings and some exercises are not. And all of these exercises that they pull to put together, they're all open source, and so do I use a lot of open source environment for my classes, so that way you don't have to buy the book. But this is a book that you would use if you wanted to do it on your own. Okay, so not required. Any questions so far? All right, so as far as grading, um everything is going to be organized in module. Okay, so if you have access to Canvas, you would see that I have the first module, which is about the class. And on the left, you can click modules in order to check out what is required. So I placed that at the top this time. Okay. And then you can check out your grades and so on as you go along. And I haven't turned on the lab for this week yet, but there are 2 weeks that we are going to be doing the exercises, and I have everything. So treat the module like a unit or the weekly task. And I have the listed tasks and objectives that we are going to be learning. And then if you click the next button, you would find my presentations, my videos, which I will be posting later on today, and also the assignments that you need. Okay. You can always download these, but if you don't have Microsoft Office, I have a page on the first module on how you can obtain a Microsoft Office license as an RCCD student. So you can download that and just use your email, your school email. Okay. So modules are going to be the things that we are going to be doing weekly. Okay. And as far as grading goes, this is a non-credit course. So, and it's only 2 weeks, so I don't take anything after the course ends. So you want to make sure that if you complete the task, then you just got to submit it so I can give you grading. And if you have a C or better, that means that you're going to pass the course. If you have below a C, that means that you don't pass the course. And I hope everybody passed because it's such an easy course. So there are a few things that we normally do in the class assignments, which I hope to accomplish every day with you. And I will explain each of the tasks. And then we would have lab, which reinforces some of the concept that we learned from the assignments. And there's some new added concepts to the lab as well. So both of these are going to be strictly hands-on. So there's not a lot of just concept based, just hands-on, and so you can program and see your output right away. Okay. And these assignments, what I normally require is just for you to take a picture of your circuit or your things that are working, and you submit that, and it's pretty easy. Okay. So not a lot of write up or anything. And the questions in those assignments are really geared for you to really see, like make an observation of what's happening to what you have done, what you have accomplished. Okay. You do have a multiple choice quiz. You have 3 options, three tries, 3 attempts. So the score that you get that's the highest is going to be recorded, and quiz are going to be due at the end of the week on Sunday. So I normally open the quiz and you can attempt the quiz now or later as long as you accomplish that before Sunday, 11:59 p.m. And it is open until the course ends, which is 2 weeks. And then after the course ends, you cannot attempt it anymore. Okay, so a passing grade is A, B, or C, and a no pass grade is D or F. Okay, all right. Any question with this? Okay, so your grade categories is broken down into three parts. You saw the quizzes already. That's going to be worth 20%. Basically, it just covers the things that I talk about in the lecture in the lab. So it helps you remember. And then your assignments and your participation is 40%. So that's going to be the completed activities and for your attendance for the session. And then your lab is going to be 40%. So altogether, it's 100%. Okay. And then basic student code of conduct, attendance. I do require attendance because when I teach non-credit course, we take census based on attendance. So if you can't attend a session, you can drop me a message and let me know. And if you accomplish the assignments, I will give you the attendance for that session. But try to attend because that way I can help you if you have questions. Okay. Um, any questions? All right. So if you have questions, please email me, message me, right? Post it, whatever you like. Just make sure you let me know. So basic policy with behavior issues, just be respectful to other students and me. And I will do the same for you. So no offensive language, no crazy stuff, right? I hate to really can a student because, they're disrespectful or something like that or offensive to others. In this course, not so much on any crazy things that we have to do. We are just gonna pretty much build the program as instructed, follow the instructions. But I do follow the zero cheating policy with the college, and I hate to have to dismiss the students at the end to due to that. If you required additional accessibility, you need to contact the DSPS department and they will send me a notification and I will accommodate. So like extra time for tests, additional accommodations, just make sure that you communicate with them first and then they will notify me and I will accommodate based on what's listed. Okay. And here's the information for my contact. Okay. I have office hours Tuesday 4 to 5 for our Zoom meeting. You can find that also in Canvas. I normally respond to your email right away, or if not within 24 hours. I'm pretty responsive via email. Okay. So if you have questions or if you need help on something, let me know. Okay. Any question on syllabus? Okay. This was also included in the announcement, the email that I sent out last week. So some of you probably got this already. All right. I'm going to stop share real quick and check the chat. Okay, nothing major. All right, so let's talk about Arduino. And so that way you would know what it is, how to work with it. And if you are following along, that will be on the lecture page. There's a presentation called Working with Arduino. So just a little bit of my background. Arduino is something that I like to use, and I have always been using microcontroller for a long time throughout my jobs and so on. So when I taught at College of the Desert, I I wrote a lot of tutorials for Code Club, and so when I came to Moreno Valley College, I created seminars for students to take, and so now these seminars became non-credit courses. So this is a really good way for you to learn a little bit more, especially in the area of computer engineering and programming or computer science. So it's really important to learn how to work with electronics, because ultimately computer system is an electronic component, right? It's actually is an embedded system, but we want to be able to how to know how to program these things, because we use a lot of the programmable devices on a daily basis. So okay, so for microcontroller, we are using Arduino, as I mentioned. And this is the common microcontroller platform for education purposes. It's very affordable. If you buy it on its own with just a USB cable, you can find it as cheap as less than $10 in some cases if you find certain vendor. As I know that a lot of the manufacturer, they increase the prices due to the demand and such, but you can get a kit, a good kit, for about $20-$30. So we are going to use the pin control for a lot of the projects. And what you need is you need to have a USB. So USB is going to be used to send instruction to the actual microboard, but it also is a way to provide power. And your Arduino can be powered with the 9-volt battery, which is your regular smoke alarm battery, the rectangular one that you would see. Or the a safer way to use is to use a power bank with a USB cable. I highly recommend, if you create something cool and you wanted to keep it, you would I would suggest buying a few dollars power bank. You can find them pretty cheap. You don't need to have a 10,000 mega ohm for it. You just need to have it where it would power at least at a 9-volt battery level. Okay. So the origin for this is to really, it was designed and released in 2005. Um, it was designed by two scientists. They are Italians, and the names you can see there: Massimo Bansi and David Cortelles. It was aimed to educate people, and be able to teach them how to be able to program these the microcontroller. You will see a lot of different type of boards like Beagle Bones and so on. Beagle Bones is made by Texas Instrument. Intel all actually released their own board, but for the industrial use, you would see IBM. That's one, and Texas Instrument, that will be the other. That will be used for like farming, manufacturing, you name it, right? We would see a lot of these, from street lights to, you know, um, warehouse controls and so on. We would see a lot of these usage. So the way that they design this is this really, the design is open source. So this is why you would see other company using the same schematic for the board to design their own, like Adafruit. You would see a lot of those. So when you go on Amazon and you buy an Arduino, you would see there are different brands like Elegoo and so on. Because of the open source, open common license, other companies were able to use this design and be able to brand their own. But you would see that if you look at the pins and everything on it, it's exactly the same as the original Arduino. So the kit that you got from iMake Innovation Center, aka Makerspace, is the original kit that I put in for purchase from Arduino itself. Okay. So the variation that you would see, you might see some of these, some of them are a legacy and some of them are still around. So you would see Borduino, Cduino, and Freeduino. So you would hear these names, which is ultimately is under the Arduino common license. Okay. Now the board that you're using is the Uno, but its original name is Genuino Uno. Okay. And here are some of the models that you see. So I always, I was always curious, like, why would they name it this way? What was it? What was the purpose of it? Different model. Why is what is the difference? So just to give you the summarized version, the Uno in Italian, it stands for 10,000, right? There's significance in the iteration of their design and how it was then be released for use. Um, and then you would see that there are models that represent the year that it was launched. Okay. Leonardo, you don't see as many of the boards anymore, but it was designed to be for a cheaper cost. So, and then if you wanted to add in some of the chips, you have to solder it on. So there would be a little bit more manual labor when you implement boards like Leonardo. The Mega is very common if you learn robotics with microcontroller. It's often used. UC Berkeley uses this. They also use Uno. Many companies, including many schools, institutions, they actually test out using the Mega. So the difference between the Uno and the Mega is that the Mega have more pins. So you would have more I/O connections. That means that we can hook more things to it, right? And it has higher storage. Like I said, flash is going to be very limited in the type of memory that's used, that's soldered onto your Uno, is less than what you've seen in the Mega. So the Mega board physically, its size is a little larger. It's rectangular and it's about twice the size of the Uno. So therefore you would have more pins. The micro is designed to be smaller. It's very small. It's compact. It's really designed for like, devices that would be housed in a very compact space. And I bought the micro before. The tricky part with the micro is that when you're trying to add more pins to the micro, it can be very limited because it's very small. Yoon was designed to have a Wi-Fi capability built in. So when you compare these two to a Raspberry Pi Zero W, uh, Pi Zero W actually is compact and it has Wi-Fi and Bluetooth capability. So embedded system is elevated, right? It's much higher in the capability compared to what you've seen in a microcontroller. But can you adapt a microcontroller to make it a little bit more advanced, almost comparable to an embedded system? Sure, you can, right? So Yoon is small and it has Wi-Fi capability. So you would likely see some Yoon in drones, okay? And then lily pads is round. It is designed to be for wearable. I've seen projects where people actually sew lily pads onto a dress and make their prom dress blink. If you ever go to convention for maker, there are quite a few artists or people that actually make wearable using lily pads. Lily pads is a little tricky to work with because the pinout is you have to use some kind of clip. So alligator clips will work really best with that. So I've done lily pad projects with Code Club at College of the Desert. It's pretty fun. So you can make like smart backpack with lily pads. You can do smart sneakers with it. It's pretty cool. Okay. And they are pretty cheap. So you can find them on Adafruit and Amazon as well. And then we have the Nano, which is the smallest, and it's used the Mini B USB. As it is smaller, it has some limited capability, but you can also find Nano available for less than $7. So the board that you see here is the Mega. Okay, this is the Mega. And so just to do a quick run through real quick, I label this so that way, I use a diagram that has the label so you know exactly what it is. Okay, so if whenever you need to have a reset is kind of like the reboot on your computer. It's usually a pink or a reddish button on your board. So on the Uno that you got, it's right near the USB connection. Okay, I'll point that out later. And when you look at the pins, okay, the A stands for analog. So if you write the instruction for digital pin and you plug it into the analog side, it's not going to work. Okay, so you see how it says analog in? Okay, so on the Uno, you would see less pins, but it will say A0 through A blah, 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 right? 12, 13. Then on the digital side, you won't see the A. That will be for the digital connection. Okay. Now, Uno can be powered, or Arduino can be powered using a USB, or you can use AC/DC adapter. Okay, that's your common DC connection that you would plug into your electronic device. It's round with the silver pin in the middle, right? Now your kit might or might not come with it. Sometimes you can buy this as an accessories. Okay. All right. The chip that they use is the Atmega, and I have another slide that goes over that. So here it tells you that it's the Atmega 2560. There might be variation of the Atmega, and Atmega is the processor, right? And for this processor, it would then understand the instructions after the compiler give it to it. So at the low level, it's going to compute. Okay. Um, then here, there's another diagram. So it gives you the, which side is the analog and so on. And then the power pins, I want to point out for area six, the power pins are important because sometime you might need to have connection to the power pin for other electronic components. So what it does is it's going to take the power that's received by the microcontroller, and it would distribute it through the wire connection to whatever components that you're connecting to. Okay. And then your analog pins, like I said, it would say analog on it, or it would say A next to it. Any question with these? Okay. Now, here I put a little note that for your RAM, it is small. It's a very small amount. It's limited. So if you run a program that requires many files and a larger program, what you will happen is it's going to give you an error, and it's going to tell you that it's overflow. It's not going to be able to store it. So what will happen is you have to make adjustment to it, and you can use some compression, but it's going to be very limited to that. So keep in mind that it uses what's called the programmable read-only memory, your EEPROM. So when you upload it, that's what it's going to use to read it. So it's going to read that program, and it's going to keep on executing that program until you turn the power off or you disconnect it. Okay. And it uses flash memory technology. And then with that, it would then use the input and the output pins. Okay. So let's talk about I/O. So the input, we would use it for digital and analog, sometime both and sometime one or the other. Okay. And we will talk about the voltage because on these devices, as I mentioned before, you can connect to a 9-volt battery. So there's not a lot of high power that goes into this, right? Compared to a computer system, computer uses way higher voltage. Only if you're looking at like a hard disk drive alone, that use 12 volts. Arduino microcontroller uses between 7 to 12 at the most, sometimes less, right? So for some of the pinouts, it's actually 1.5 volts to 3 volts. It also depends, and we can regulate that using resistors, where we can have more flow of current, or reduce that current. Otherwise, you would burn some electronic components if you have low resistance. Okay. So it can be used for like LEDs. It can be used for temperature. Okay, like to sense temperature. It can be used for sound. It can be used for a lot of things. You can definitely design a smart solar panel using microcontroller, and so on. So the kits that you see industrial wise or through consumer, right, for home improvements and things like that, a lot of these kits have microcontroller built in. Okay. For your output, keep in mind that when it's off, it's 0 volts, right? No volts. And then when it's on, that's going to be 5 volts for the digital. So when you say digital pin, if on LED, in order to turn on the LED, it needs to send 5 volts through that connection. Therefore, the LED would turn on. Okay. For the analog output, we would use this to control motor, like speed. Things, knobs that we would turn, and we would do a lab this week where you would control like your LED with an analog. So you would push it, you would take digital and convert it to analog, and then to control the brightness. So when do you actually see this? If in your house, if you have a knob to adjust like the ambience of your light, right, you can design a kit for that. You can design a kit for controlling sound, low to high. You would use analog output, like pitch of sound, brightness of your lights, motor, right, how fast or slow do you want certain things to rotate. So it's just very cool. Okay. Then on the next part, here it shows you how the chip would fit with the sockets. And earlier we saw that the Atmega on the Mega uses a little bit different processor. So here you would see Atmega 328. And inside this processor, it includes memory, processor, and instructions for I/O. Atmega is created by Atmel, right? So if you Google them, you would find different model of their chip. And so they are one of the major microcontroller manufacturers. So if this interests you, if you wanted to go for, computer engineering at low level, um, and for the assembly level, it uses a little bit different than what you see with embedded system. Embedded system uses ARM. Um, Arduino uses a different language, but it's very similar to my course I teach, LC3 or ARM. So for PCB, this is a files that they use, basically give you the blueprint or the schematic of how the board would be designed. So when you buy motherboard, you would have, the manufacturer would have specific schematic for the model of the motherboard. So very similar to that, the Arduino, the microcontroller, would have the schematics for the diagram. So for it's power control board. Okay. And when you get into electrical engineering, it would get further into how you can design that. Okay. You have to learn AC/DC, digital, and all of that good stuff. So here gives you an overall understanding for the voltage. So 7 to 12 volts. Anything higher, you will fry the Arduino. So if you plan to plug a huge battery to your Arduino, keep in mind that it will, when you send it, give it a high current and not regulate it. So I don't recommend anything above 12 volts battery for it. If you use a power bank, it's actually controlled through their USB. So it can be powered through the USB with the power bank. For the DC, you will get a constant 5 volt being sent. So, microcontroller is pretty simple. You give it power and it's going to do whatever you tell it to do. Okay. So you can connect it with battery through your house socket, right? And I highly recommend using surge protector for any computing devices that you're connecting to, even your smartphone that you're charging. Okay. Use the surge protector. Um, So reset button allows you to reset it. So if it's like gets stuck or if something's wrong with it, you can reboot it, reset it. Okay. And then just re-upload your program. And it's just going to revert back to whatever program that it would be used at the start. So when you reset, you just reset the entire system. So you will likely need to re-upload your program and run the program. So the 6 pins that are labeled A0 through A5, those are your analog pins. Okay, remember what we said. It's used for motor, for dial, for sound, and so on. And you would have to use some kind of resistance to regulate it. So we would use something like this. Okay, those are resistors of different sizes. And on the resistor, they would be labeled with different ohms. So in high resistance, you would have low flow, right? Think about like uh, uh, a hose, a garden hose. If you put a filter, a very thick filter in, you're gonna have low flow. So if you have a high resistor value, then you're gonna have low flow of currents. If you have reduced resistor value, a low resistor value, you're gonna have high flow. So if I have a less thick filter, I'm gonna have more water flowing through the hose. So think of it that way. That will be my analogy. Your digital, it's gonna go from 0 through 13, and you can use all of those. Okay, and when it's on, it's 5 volt. When it's off, it's 0 volt. Okay. Now the RX and the TX, R stands for received and T stands for transmit. Okay, and that's going to be pushed through your USB connection. All right, just a little bit more on the actual components on the inside. So for the processor, above your processor, you would see these. Let me switch camera real quick. Okay, 1 second. Let me get on the. I want to show you. Okay, everybody sees this? So you see this right here? It looks like an oval metal piece. Okay, so this is the quartz that we're talking about here. Here's your processor on the Arduino, this part. Okay, so usually you would see the quartz crystal located right near it. Okay, and then these individual chips are for specific things, but this is your processor. This is the quartz oscillating crystal right here. Okay, all right, let's come back. So this is going to be, it talks about how it's going to tick, and it's going to be 16 million times per second. So very rapid, right? But compare this to something on your PC, not quite as fast as some of the boards and the PC that we would see. So the reset switch is at the top left. So if you're looking at not my share screen, but you would see it next. It's like a little round button next to the USB. Sometime that would be pink, or in this case, I'm using the Arduino kit original. That's going to be white. Okay. All right. Your serial programming connections, that's going to be on the right hand side. So 600 million operations per second. That is correct. Okay. So your reset is right here. You see that? The reset? Sometimes that's like pinkish. If I have some of the older ones, that's also pink there. And then the USB has its own chip. And when you work with microboards, you're going to see all of these. So every component that you would see would have its own chip. Like the power would have its own chip. It has an amplifier that's soldered on. And so your USB chip, that's how it would know that it's connected with the USB. It's going to be next to the USB socket. Okay. This allows it to convert the signal from USB standard to the lower level for the board to know. And for our computer, it would then see that it's that chip actually, it's going to send a signal saying that the Uno is connected through the COM port, which is the communication board. All right. So we can do a lot to our Arduino. we can add Ethernet connection, Wi-Fi, motor, relays. So you will be working with, some of the motor later on next week, and then also using switches this week. Okay, so let's be familiar with some of the components. So a circuit, what you see in the picture on the right, it's a built circuit on a breadboard. A circuit is just a path that it's going to start and stop in the same place. So think of it like a circular path, right? But it's going to start and stop at the same place. So when we build the circuit, we would use a solderless breadboard. And this is a solderless breadboard like this, okay? But if you're looking at the camera picture, um, they are often either white or sometimes comes in green. There are breadboard that are soldered breadboard where you would use a solder iron to solder on the components. I'm seeing the chat. Sorry, it takes me a second to get it open. All right. Will we make a web server? Not in this one, but we will likely do a web server. We will get close to setting it up because I don't think iMake Innovation Center have the Wi-Fi adapter for your microcontroller, but I do have yeah, so solderless mean that it's not soldered on. That's correct. But in the Raspberry Pi class, we will do a web server for game. Yeah, I just don't have the Wi-Fi components for all of these kits. So, and I asked them to look for it. So, but anyway, I can point you to some direction on how to build some of that. Okay, so electricity is gonna be on the path and it's gonna flow through all your electrical conductor. What are conductive, right? Metal things are conductive. I have used copper tape, that's also conductive. Some lead pencils, number 4 lead pencils, not number 2, are conductive. Of course, water is conductive. So you can find a chart of what's the highest level of conductivity. So when we're using wires, like jumper wires like these, you notice that there's metal inside, right? The metal pin inside, that's conductive. So you can even use foil. I've done foil. Maybe next week we'll do a project of doing foil piano on the Arduino. Because it has less metal when they created the pencil. When I did CyberCamp one year, I actually have them draw piano keys and then wire up the Arduino and connect to it and with copper tape, and it works. So when you touch the paper with the drawn lead, you can play that key. So number 4, I believe, is conductive. Yeah, it's pretty cool. So we'll do something like that in this class next week. I'll find the projects that I wrote. So what you can do is you can think about how you would use the conductive or electrical conductor to be able to connect the components. And if you look at all electrical components, right, they have some kind of metal pieces, metal leg that will be connecting to your breadboard. Your DC sources is always going to have 2 sides, going to be positive and negative. So the positive side is going to be higher in voltage. So the digital side is going to be 5 volts. The analog side, they can regulate from 1.5 to 3 or even 7 volts. The negative side is going to be lower, right? And we always need to use ground, okay? And normally, I don't care what wire color you use, but by standard practice, people use black, brown, or gray for ground connection. Okay, if you ever look at your power supply in your computer, you will see those. Okay, so the breadboard, you see that on the right side, your wire, those are the wires, and these are male to male. So how do I know it's male? There's needle pin on both ends. And sometimes we would use male to female, so only one needle pin on one end and the other one you would insert So those are male to female. Um, and then we would use resistors like these, right? And I try to find the standardized way that they actually color code the resistors, but not always the case. Some manufacturer would follow the standards and some don't. The safest way that you can do is you can refer to the label on the resistors, or you can look up a chart on the internet to find the resistors. And sometimes when you use the wrong resistors, it doesn't work. So just keep in mind, if you use too high of a resistor, it causes too high of a resistance. There's little flow, so it didn't receive the signal that it needs to, drive that motor or whatever. You're gonna get issues. So check your resistor. Make sure that you use the close enough or the right resistor. Okay. And then components are like LED. This one is a piezo, right? It's a little speaker and it has a really high pitch. So we'll do a couple exercises on piezo. And then we'll do buttons. Okay. So all you have to do is plug the USB in. It should be connected. And then for the when it's connected, you're gonna see the LED blinking. It's the little yellow amber blinking light. And then everything is good. You're gonna see the green LED, okay, on the board once it's plugged in. And it does have a blinking sketch that's built into it, so that's why it's blinking. Sorry, it's always a little laggy when I click chat when I'm on Zoom here. But so there are some additional resources. So what do you need to program? You need to have an IDE. Okay. You can use their web-based and there are websites that actually allows you to connect your Arduino to the computer with USB, and you can still do it that way. It's like it functions as an alternative IDE. There's web IDE. So if you visit the site, you will be able to download, and for different operating system, of course. All right, 1 second. Should I have everything set up by the end of today? Sure. We're gonna try to do the first assignment today. Okay, I'm almost done with the presentation, so sorry. First day is always a little more. Okay. If you want, you can work ahead if you like. All right. So the documents that I'm giving to you is in word processor, Microsoft Office. Keep in mind that when you copy and paste things over, it's going to convert the symbols because they're encoded differently for different applications. So if it's throwing error because of the code, right? Check the the symbol, the characters, right? Like curly braces, semicolon. Uh, it's best that you type it, right? That way you would learn, right? The syntax and all. But if you copy and paste it, just make sure that those symbols translate it properly. When you save those files in the IDE, it's called Sketch, and we would have a sketchbook that comes with all the sketches. Now, if you don't give it a name, it's going to default to that, and it's saved to your C drive under Arduino. You can go File Save As, and it will point you to the path where those actually you can find them. If you delete your sketch, you will likely have to remake it in order for it to work, of course, because they are programmable files, right? So in the PC, you would find it under Documents under Arduino. That's the path. All right. I don't know why it's not popping up. Would other versions of Arduino family and other brands that make Arduino, such as, yes, you can use the same IDE. And Adafruit makes a board called the Red board, which is equivalent to Arduino. It uses the same pin information, same everything, same instructions for the library. So yeah, but if you buy like Elegoo Arduino, I have one here actually. This is from Key Studio, and it is Key Studio Uno R3. You want the R3 version for the Arduino kit. Okay, and you can buy different kits. They're pretty much the same. Is NetBeans sufficient IDE? You can use. I don't recommend using other IDE for this because um, I'm going to show you something real quick. Okay, 1 second. So this is Arduino IDE. There are specific function that is set up for it. Okay, voice setup is to be used if you run something once. Loop is to be used to do something loop. Can you write it in other IDE? Sure, but you gotta make sure that it's in this format, and you have to save it as its file. Otherwise, right? Otherwise, it would not work. So it is specific for this type of microcontroller, just to save all the hassle and all the extra work that you have to do. Use its IDE. It's not the best, but it will have to do for the Uno. Yes, that is correct. Margot says that's correct. There are different types, uses different commands. So it's not ideal to use other IDE outside of its own. The library that comes equipped with it and all the things. Okay. All right. So when you plug in your Arduino, make sure you check for the green LED light. Okay. That means it's ready. One of the things you need to do is you need to configure and check the configuration. What do I mean by that? Here in the IDE at Tools Options, if it's connected properly, make sure that it sees your board as a COM. It might be COM1, COM4. It's a communication port, and that's how it's able to send signal, right, from, or send the instruction, the program that you write from your computer to it. Okay, so it should make sure that this is selected under the tools option. Also, make sure that we have the right board. This, all the newer board actually is, it automatically detects it, but when you're working with some of the older model, you make sure that you select the right boards. Okay, and as you can see, there are different types here, so we can, it selected for me Arduino Uno. Okay, so that's important. I do write the instruction in the earlier, the beginning lab, but it's not always the case down the line. Okay, so I put here COM1, COM3, COM4. For the Mac and the Linux, find your device near the bottom of the list. Okay. So what's happening when you write the program and you save it and you click the upload button? So it's gonna compile your program. When it compile, it's gonna break it down to the lower language, which is 0 and 1s, right? The machine level. And then it's gonna send it to bootloader. And on this particular microcontroller, there is bootloader. Then it's gonna store it into the flash memory. CPU is gonna then receive the instructions, interpret that, and then it's gonna give you the output that's needed. So if I'm instructing in this example the LED to blink, then this is the process for it. Okay. So we want to upload our program, and then it's gonna go through and it's gonna compile, interpret it, store it, interpret it, and then execute it. Multiple choice, super easy. You can use notes and presentations, 60 minutes for 10 questions, 3 attempts So the highest score in your 3 attempts are going to be recorded. Okay, it's a non-credit card class. I'm not going to go crazy with that. They're about 10, sometimes less questions. All right. Just a few things on the programming side, right? I mentioned void setup is for something that run once, okay? Like this one. That means that I'm gonna use pin 13 and it can be output. That means it's gonna light using, it's gonna output through pin 13, and high is when it's gonna send 5 volts. So it's gonna turn on. When you see low, it means off on the digital side. So on the parameter, you would see here is what we would have the commands, and it would say turn on, right? Send 5 volts to 13 pin there. So it's going to do a digital write. So here I have the explanation for that. Pin set mode to pin 13 output, set pin 13 to high based on the noted arguments in the parameters. So inside the parentheses is the parameter. And then, so there's only 2 mode, either pin mode or digital mode in this program. Okay. And the function that will be void setup, and the void loop is where we want to repeat, just like how you would know a loop would be. If you wanted to keep on blinking, every 5 seconds, we would then put it under here. If we wanted to do it only once, we put it here. Okay. So, or we wanted to wait, we would say delay. Okay. All right. So we are going to do the first exercise. Everybody ready? Okay, so the first thing that you need to do if you haven't done that already is to download the IDE. Visit the link. Where is this assignment from? Well, it's going to be, if you have access to Canvas, it's going to be here. Okay. If you click that, you can download it or you can view it within the actual page. Okay. All right. So if you visit this link, it's going to take you to the software download page. And they do have the updates to this. So once in a while you can update it, but this should be the recent one. So if you're using Mac OS, you would click here. If you're using Linux, make sure that you check your processor. So if it's new, then 64-bit, then you would click this one. Now on the Windows side, you can download the zip file or you can download the installer and run it. Okay. And keep everything default. So if when you go through the installation, you should keep everything default. So it will put a shortcut on your desktop and so on. Now on the Linux side, if you're using ARM, this is for smart devices like tablets and things like that. It would use these. Okay, but on the Chromebook side, you would do these here. Okay, so if you can actually use smartphones with Arduino IDE and such using the ARM, like the Android ones, I mean. Okay, a little tricky though. You got to read a little bit more documentation on that. All right. Now, if you don't use the IDE that's native, download it and install, you can do code online. Here's the web editor. So now web editor is reliant on web connection. So, the downside of this is halfway through if you lose your internet connection. Cloud, it's supposed to save everything simultaneously, but, can't be 100% sure all the time. Yeah. So if you wanted to update the libraries, I would recommend updating the libraries for it. So if it tells you that, you should. All right. Okay. Any other questions? So the first step for step 2 is if we already got the kit, we already got the download, we need to install the IDE. For the first day, all I want you to do is to work on the day 1 part A and B. Okay. So just to give you a little bit more details, I actually wrote everything out. But this is an LED and they come in different color. It has two legs and LED stands for light emitting diode. Okay. So for part A, all you need is the Arduino and the LED. Okay. Now, after you got the LED, the Arduino, and your IDE installed, everything is good to go. Here in this one, we are actually going to use a variable. Okay. So when you write this line into your IDE, this is a data type, int, for integer, right? Some of you are familiar with programming, so you already know that. Some of you haven't learned programming, so this is for integer. So you would have int LED pin 13. So here is the name of our variable, and here is this data type, okay? So for C language like C++, C, and Java, it is a strongly typed language, meaning that we have to specify the type that we're working with, okay? So you would say int LED pin, and then we would say 13. So that means that we are going to use the pin 13, okay? Then we are going to use a pin mode function, and we are going to put that inside the setup function. So we are going to put it inside this void setup. Why is that? Because we only need to set it up once. So here in this part of the program, you notice that this is inside the curly brace, and you need to indent for here. So you need to tap in. So what we're telling the system is that it needs to set up the pin, right? And it's going to use the variable that we had declared, which is LED pin, which is pin 13, and it's going to output through that. So it's going to send the electrical signal to the pin 13 to turn it on. Okay? Now for the second part of the program, we are going to put it into a loop. So here we're going to say, we're going to repeatedly do these things. Okay, so you need to put it into the curly brace and then indent it. We are going to digital write. Remember that we talked about earlier, very similar to the example in the presentation. We are going to turn on high. That's going to be 5 volts for pin 13. Then it's going to wait 2 seconds. So the delay here, this command is await. So it's going to pause, right? 2000 means 2 seconds, and then it's going to turn it off. So it's going to turn on for 2 seconds, turn off, wait for 1 second, then turn back on again, and it's going to keep doing that. So this is how we make it blink, right? We're going to make it blink. So it turns on for 2 seconds, off 1 second, on for 2 seconds, off for 1 second. And that's how we are instructing it. Okay. So then once you have this, you would then upload it. But I would upload it after I connect the LED. Sorry, I put it in the wrong spot there. Okay. So when you connect the LED, you can connect it directly into the actual thing without using the breadboard on this one. Okay. So here, it's important that you read this part. LED is polarity. So what happens to an LED when you reverse polarity? Likely that it will pop. It would burn. Okay. Now in the legs, the long leg is going to be positive, which should be connecting to pin 13. So when you're looking at the LED, the longer leg is going to go to the positive side, and the shorter leg is going to go into the ground, which is G and D. Okay. So when I connect, as the picture shows, the longer leg needs to go into 13 and the shorter legs is going to go into the ground. Sure. Yeah. If you break one of the LED, it's not a problem. They can replace LEDs. Okay. So when you connect, you would then connect. Remember, the shorter legs, right, is for the ground. So you would take the shorter leg connected to ground and then the 13. If you uploaded your program as we instructed, you would then see the blinking LED. You can use red, green, whatever, float your boat. I don't, the picture shows red, but, and red is commonly, it's actually more visible than yellow and the other color. So you would see a lot of illustration using red because it's very clear. So you can see that. Okay. And they burn out too. So when you reverse polarity on the LED, sometimes they burn. Okay. Any question? Okay, so I'll give you a minute or so to work on that. Let me see if I can pin my, I'm sure you guys pin. So LED, take it and then connect it to your digital, right? 13 and ground. And we don't need to use a breadboard for this one. Do we need a resistor? Not yet, not on the first exercise. So follow the instructions. Okay. So download your IDE, install it. Then what you're going to do next is you're going to open it. And if the font is small and you have a hard time seeing, okay, if you click edit, you can change the font size. Okay. In the IDE, if you want the line numbers, yeah. So Victor says to go to edit and then click preferences. Very good. Good point. So that way when it throws an error, it tells you which line it is. You would know which line it is. Okay. Any questions? Are we okay with this? This is pretty easy. Okay. So when you finish with that task, just check, is your light blinking? Okay. What happens when you change the delay time? So what I want you to do is play with it a little bit. Make it flash higher or lower, right? So if I wanted to make it blink faster, I would then decrease the delay value for inside the parameter under the delay command. If I wanted to blink slower, then I would increase it. I would make going from 3,000 to 4,000 or 5,000. Okay. And then when you finish, you just take a picture for me. You can use your webcam to do that or your smartphone, showing that your light is working. And that's what you're going to submit for the assignment, is the picture. Let me see. I don't have a preferences option under file, Albert. Okay, so for those of you who are trying to change your preferences on your Arduino IDE, you go to file, let me re-click it. Go to file, okay, and then preferences is right here. Display line numbers, okay. And then you can, if you needed to make adjustments. So if you wanted to change your font size to larger, you can also change that here, okay. And the default, you notice that I have it under documents. The default is under Arduino. I'm using Windows computer, of course. But if you wanted to set it up where it's stored in a certain folder, you can. That will have your code and everything that you need for the course. Okay, but I just keep it under the default is fine. Okay, so if you select the line number, it's under file and then preferences. Other comment or questions? It is sort of a beginner course. It's 2 weeks, so I can't go in depth like and super slow at the same time. So it is a beginner to Arduino, yes. Okay. And most of the program stuff, I have written the program for you, so you just have to follow it. Okay. Other questions? So in this program, right, I do a recap also at the end or also throughout the program. We learn a few things. How to declare a variable. And a variable, what it is just a location in memory, right, for to store something like a value. And in this case, we store the number 13. And that number 13 represent the 13th digital pin that we use on the Arduino. Okay, that's how we connect our LED, right? And then in the void setup, this is a function, it's pre-built. So in the setup function, we wanted to output to pin 13, right? Which we declared. So this pin mode right here allows us to specify how we wanted to output to a pin. Okay. Then in the loop, we learned that how to repeat. So we repeat by turning on high, giving it 5 volts, light up the LED, keep it on for 2 seconds. We're going to wait 2 seconds there. So whatever value that you put here, that's going to translate to 2 seconds. So 2000 is for 2 seconds. If you wanted 6,000, that will be 6 seconds, right? If you reduce it, it's going to be less. So if I wanted 500, it's going to be super fast, okay? And then we are going to turn it off and then turn it off for 1 second. And it's going to keep doing that because it's under the loop. Okay, so there are only 2 sections to the program, the void setup and the loop. But you notice that when you declare the variable, you need to put it at the top above all of those. Okay, otherwise, right, it's only going to be local inside that function. It won't be accessible for other functions. Since we're using 2 functions, right, setup and loop, we want it to be accessible in both of these. Okay. Okay. Any other questions? So when you're done and you wanted to upload, you're gonna click this button. See, you put your cursor on there. It's when you finish writing your program, you can upload this. Okay, and it's gonna save it to your sketchbook. Now, if you wanted a certain name, you can do file save as, and then you can type in the name for your file. Okay. Any question on the first one? I'm going to do the second one.
I had a question.
Questions?
When I had a question.
Sure.
When I push the code, it popped up a serial port wasn't selected, and it's giving me the option of COM1 or COM5.
Yeah, so you need to go tools here and then go to port and make sure that the one that has the Arduino Uno in the parentheses is that one. So you have to connect it
Okay.
first. Yeah, if
Okay,
you
thank
plug
you.
in the USB, it will tell you which one. Okay. Because if you don't have it plugged in, it's not gonna see it. So plug it in. Okay, make sure that we always select the one with the Uno. And then make sure that this board is always recognized. It will say Arduino Uno. Is that okay? All right, so next part B. Now we get to do breadboard. Okay, so after you have your LED, you can unplug it, and then after you take a picture, of course. Okay, so follow the instruction there. So for those of you who register late, right, you don't have access to Canvas yet, but you will once they activate everything, and you will have this document within Canvas under the week 1 module. Okay. And you can finish it later on throughout this week. All right, so for this, the second one, my goal is to get you to complete the second one today or before the end of the week. So in this one, we are going to use an LED, but it is going to be RGB. Okay. So I'm going to stop share real quick. So the RGB has 4 legs. You guys see that? It's that one. Okay. And it's clear white. So red, green, and blue. So we can actually make it blink other colors by programming in variations of the density of the different variations of the color. Okay. So this is another form. And in this one, you are going to use a breadboard. And I try to put picture for everything too. The RGB. And then you are going to use a resistor. Okay. All right. So back into screen share. So here it gives you a little bit of explanation, and I want you to read these because this is important for the knowledge, and also, you know, because you're using certain things, and I put in the description and why you're using it. So we are going to build a circuit, and your circuit path is going to be required for the electricity flow. And we have to be able to create that, otherwise we won't have a flow. So it's going to go from higher voltage to the lower voltage. So we want to make a conductive path. Where would we find the 3-prong component that you showed us? They should have given that to you. If you got the kit, it might come. So here's the Arduino kit that they gave you. Okay. And then if you open it, there's a boxes inside. You would see the electronic component starter kit, this box. You slide it open. And then you would have these LEDs in there. Check to see if in there, I specifically request for RGB and they bought a bunch of them. So if they forgot to give it to you, then they're gonna get I'm gonna give it to them if they don't give you the right parts. Okay. So check in this and it's in this box. Okay. Starter kit electronic components. They might include that in there, or some they probably put it in there with the rest of the extra stuff. So you can find, so since we're on here, let's talk about some of these so you know. Okay. Battery adapter, 9 volts. Okay. You are going to get these little knobs. They are going to go on top of these bluish things. This is for your button. So it's like this. We're going to do this for the lab. And it will have an arrow on the top so you can turn it. So it's like a twist and turn button. Okay, so we'll talk about that. This is a piezo, which is a speaker. Don't take the sticker off because the sticker helps you knowing which side is positive. Okay. And the RGB is 4 leg. It is clear and it's an LED light. Okay, so look for that. These are resistors. They are sometimes loose or they come in a pack like this. Okay. For the digital pinout are the only number with the, yes, capable of, okay, no problem. Okay, we got that. You will also be using, for this week, I will post the stuff. You will also be using what's called a button switch. Okay. So just take some time. There are different types of buttons. There's this kind of button, right? They come in different color. And then there's the little button. So you see some picture that I clipped. So now for the second one, what we're going to be doing is we are going to make colors with our RGB. So here it talks about the conductive path with the higher voltage going to low voltage. And you want that flow. You want from higher to lower. So keep in mind that conductive path, we're going to go from higher to lower. It's kind of like, my analogy for this is kind of like, you know how the ocean has a lot of water and then it's going to flow into the stream, which is lower. And then from the stream, it's going to flow into the city. And then from the city, it's then going to get lower. It's going to flow into your house. So for your conductive path, you want to go from higher to lower. So that way you would have a flow path, okay? So that way in that path, using that path, you can have electricity to your components like an LED. Now resistance, when you're using a resistor, it's gonna limit that path. So think about if we're thinking about the ocean going into the stream. So let's say if I put a net right between, right, I want to put a filter or rocks to kind of keep the stream flowing steady but slow, right? So when you're applying the resistance using the resistor, what that does is it's going to regulate the flow of that current, okay, for that circuit. So when you're working with resistors, it should be added to the circuit to complement the active components. So for example, I might have a current that's like 7 volts, but my LED only needs 5, right? Current is not going to be steady and the same all the time, just like water. Sometimes it's fast, sometimes it's slow, sometimes it's a lot, sometimes it's not. So in order to really regulate it, what we want to do is we want to put in the resistor, so that way it would control and keep it at that constant, um, at the constant ohm all the time. So if I wanted 5 volts, then I would use a certain resistor to make sure that that flow, that current that I'm receiving is always going to be that size. So this is why you would see resistors being applied. Okay. So you can make it where we would limit the current. We can also divide the voltages, especially when we're dealing with like an array of things, a group of LEDs or, speakers or whatever. Okay. Or we need to do some pull up for IO, and we'll talk about the pull ups in the next one. Okay. All right. So here for your RGB, your positive is going to be the longest leg. Okay. And then to the left of it, that's going to be the red. Okay. So for your RGB, it's best that you kind of spread out the leg, but not too much, just to make sure that you can fit it into the holes. Because when it comes, it's going to be very straight. So you wanted to kind of spread it out a little bit, like a fan. Okay. And then to the right of the positive, you're going to have the green, and then next to the green is going to be blue. And if you're looking at like the old school monitor, right? A lot of the screens and all the things that we see, these are the basic colors. And the combination of these colors are going to give us other colors like magenta, teal, right? Purple. So we can have a combination of color to give us other color in the spectrum. Okay. So here it gives you the schematic on how that would be. For 5 volts, it's going to light up the LED and then it turns off. So when you apply resistance, it's going to keep that current flow, because the battery, if I plug in a 9-volt battery, it might give it 9 volts. But I wanted to keep it where it's 5 volts for my LED, so I would use the resistor to control that. Okay. And so when you hook it up, it will be like this. Okay. That's one picture. And the fritzing diagram is better. Okay. So I put in the chart for resistor color code, and they come in blue or brown or sometime gray. And like I said, sometimes it could be hard to determine. So it would be best that you would find the proper resistor to plug in. This is the one that they gave me with the kit. Let me see if there's something printed on this. So all you need is going to be 270. So now what happens if I use 330 or higher? Your LED might not turn on, right? Or it might be very dim. So if you use higher higher ohm resistors, it's going to be very dim. Okay. So you can use up to 1K. So you can use up to 1K, but it's going to be a lot dimmer. Just keep in mind. Okay. So on this one, you have the flexibility to use other ones. You're going to need a breadboard, and then of course your Arduino and USB. And you're going to need the jumper wire. So in the kit that they give you, there are 2 different types of wires. Where is it? I took it out already. So this is a jumper wire, right? And then the smaller ones, these are called preformed breadboard jumper wire. It's designed to connect one channel to another channel on a breadboard. Okay. And these are your regular jumper wire. If they give you other ones, it might look like this. I buy hundreds and hundreds of jumper wire because I lose them a lot, or sometimes I don't want to unplug them for other projects. So you just only need 4 of those. Any color you want to use is fine. Okay. Then next, you're going to build the circuit. So for the RGB, this is going to be, we want to use the resistor to prevent too much flow. Because if you don't put in the resistor, it's going to pop it. It's going to burn it. So you want it just about a right amount of voltage for your LED lights or any of the electronic components. Okay, because you know, you don't want it to give it too much, but if you give it too little, it might not even light up. Okay, so PWM stands for pulse width modulation, and it's a way that we would control the power, how bright we want it to be. Okay, and so here it talks about how every 1/500 of a second, it will output to produce some kind of pulse. And we would use a function and a value to control the pulse. So if you have it at 0, it's not going to give you any pulse. But if you have it at 255, that's going to be the max, the highest. It's going to go to the next pulse. It's going to last all the way there. So here in this, it shows you a little bit of a way on how that would be. Okay. So how these works is going to be, it's going to use the pulses, and we are going to put in the value for that. So this is the fritzing diagram. You need to put in the 3 resistor, right? And if you wanted to stick with the color like this, you can. So red, green, and blue. So we know which one, but you don't have to. And then you would plug it into the pins like it's shown. Importantly, we have to have ground. Okay, we have to have the ground. And if you reverse it, it's not going to light up. So that's one sign. After you upload the code and then nothing happens, so check how you connected the hardware first, and then, you know, check your resistors. Also check your code. You might have entered something incorrectly. Okay. Okay. So after you put it together on your breadboard and you connect it to the Arduino, you're going to write the program. We are going to use pin 11, 9, and 10. So red is going to be on 11, green is going to be on 10, and blue is going to be on 9. So when you program for microcontroller, if you can specify the variable. Right here, we declare the variable for the pin. If you can specify it as clear as possible, that's going to be helpful. It's going to be helpful when you troubleshoot it. So if something is not working, I can go directly to that area to see why. Is it my connection? Is it my code? Okay. And we're not using the anode, so you don't have to uncomment that. In the setup, we are going to output for all of these 3 pins. So unlike the other one, this one has 3 colors and in 3 legs. So you have to specify that in the setup. Okay. Then in the loop, what are we repeating? We're repeating how it's going to be flashing. So here we are using the values in the parameters to represent the pulses, right, on the red. So we're going to set the color, right? It's going to be red and then off, the other ones. And then for the green, since it's the second leg, so it's going to be off, right, green and then off. And then for the blue, off on the red, off on the green, and then red, blue turn on, 255. So 255 is going to be max and 0 is going to be minimum. And then if you want yellow, how do we do yellow? Well, we can do a red and a green is going to give you yellow. Or what if you wanted to do purple? You're going to mix red and blue, right? It's kind of like mixing paint, right? You give it a 80% of this, 80% of that, or 100% of this and 100% of that, you're going to get a different color. If you want it aqua, you're going to do green and blue together. So that's how we're able to output different colors. Now, unlike the last one, you also create another function. This one is defined. So we are going to set the color. And we wanted to make it where red is going to be 255 minus red. Green is going to be 255 minus green. And 255 minus blue for blue. We don't need to do if and NF. So here we are going to write it out in analog. So we use analog write command. And we are going to output red pin, green pin, and blue pin. So all of this is going to tie everything together because we had used set color up here. We got to define the function. It's kind of like how your parents tell you, do your chores, right? Then you would then have to know what kind of chores that is. Is it doing the laundry, mow the lawn? What is it? So when you tell the computer set color, you got to say what it is. What is set color? Like, what does it mean? So it's going to mean that it's going to take the red value, use it in the parameter when it writes it out in the analog signal. Okay. And same thing with the green and the blue. So once we put everything together, finish our code, save it, upload it, and you should see the color. Okay, if it's not showing color, like I said, check your hardware connection, check how your light is connected. Okay, check your resistors if you're using the right resistors. And if all of those things are correct, check your code. So if you want the brightness adjustment, remember that these are numerical values that you're using for PMW. So then you would just then adjust it. And we can mix colors by adjusting things too. Make it lower, higher. It's your program. Your circuit, you can do whatever you want. Okay, what happens when you modify or adjust that? So take a picture of it. You're going to upload that onto your Canvas assignment for part B, assignment 1. Everything can go all together. Okay, so don't submit it yet. Just save it, and then when you finish tomorrow, then you can send everything in. Any concern or questions? Is there a group Discord? No, I don't use Discord. I'm required to use Canvas. But you are welcome to create a Discord and invite your classmates in there to get help or whatever. Can we keep the Arduino on while swapping parts? Yes, you can. You just disconnect it from the Arduino for safety.
I'm sorry, I had another question.
Sure.
Those wires that you have over there, like the yellow and green ones, next to the jumper cables, are those also jumper cables or no?
Yes.
They are.
Like
Okay.
these right here?
Yes, those ones. Oh, okay.
They come with the kit that they gave us, the Arduino kit. So yeah, they are also jumper wire. I don't like using these very much because they're not as flexible, but they are that you can use them as, most of the people, they would use them as a breadboard preform wire. So on the
Because I
breadboard,
didn't get any jumper cables, so I was just asking to see.
Yeah, you can use these as jumper
Okay.
cable. They are conductive. But I often use them to connect channels across breadboards. You can do it this way. You can, your breadboard is attachable. You can make a larger piece out of it. But yeah, you can use them the same way.
Okay.
The little ones are just connecting, crossing the channel. So we would use some of those on the next one. But yeah. Um, I will, if you're close by MBC, I will tell them, you can always come in and pick up additional parts. They're open 7 to 5. Just give them a call or send them a message. Oh, great. Thank you for making the Discord thing. So my goal is to give you the foundation, and I want you to take this and elevate it to way more, right? Like after this class, you can make all kinds of things. So I'm just going to give you the foundation, and you should have the flexibility there. I put in the link on there are a lot of links um, on Canvas. Let me show you. Okay, Instructables is a good one. Spark Fun, they have their own board, but so if you want more projects to do, right, you can use the book that they give you in the kit that comes with the kit, or you can use the Arduino resources page. I put in some of the Project Hub. Um, you know, you can also get certification with Arduino. Um, I use Hack.io or Hacksters is also pretty good. They have like different stuff. So now people post projects, and I'm gonna tell you they might not work 100%. Okay, I've done this one before, Auto Robot with 3D print. This is pretty cute. So I think the creator for this, they put up the STL, so you can also 3D print with iMake Innovation Center. Just let me know. I can send the file to them, or I can have you send the file. You can go pick it up. But you can make a lot of different stuff with Arduino. Like this one's pretty cool. So Google did something similar to this. They did like a Google board where you touch it and it turns on, and it turns on different color. So you can be creative and do all kinds of different projects. Okay, so there's some example projects you can find. Now the project that I selected for this class, because we have limited components with our kits and things like that, so um, I don't have a vast amount of projects that would require a lot more, but you can definitely do it if you buy the parts. Okay. So my Arduino collection is pretty big. Like I have a lot of parts. Like whenever I'm into something, if I want to make a project, like I bought like LED string strips like this, so you can do a lot with it. Okay. And if you also need parts starting in the fall, you can always stop by iMake Innovation Center. They have tons of stuff. I bought a lot of stuff for students to use, so you can go in there and borrow parts if you need to. Okay. So now at the end of the semester, when you're returning, I don't mind if you're returning the kit uh, like with your projects already built. You don't have to put everything back in the box. You can return the project that's already built. They wanted to display that. But if you prefer to put everything in the box, so it's easier for you to drive it and drop it off, you can. Okay. All right, questions? Okay, I'm coming close to the end. Please type your name into the chat so I can input your attendance so you can receive credit for today. If you haven't done that, and I'll stick around for questions. So target is to complete A and B today. And then if you like, you can work on tomorrow's stuff too, which is the next two. And then I will release the lab for the day 3 and 4. And that's basically all we have to do. All right. So that's it for me. I'll stick around until 4 p.m. if you have questions. Have a good afternoon, and thank you for joining. I hope you have fun. You're welcome. Take care, everyone. Thank you. Let me stop recording.